In the world of software development, versioning is a critical practice that ensures consistency, compatibility, and reliability of code assets and packages. Versioning helps teams manage changes, track progress, and maintain stability across different environments. This presentation will delve into the intricacies of designing and implementing a dependency versioning strategy, focusing on semantic versioning and date-based versioning. We will explore their importance, best practices, and how they fit into the broader context of build and release pipelines. Versioning is essential for several reasons. It helps in tracking changes, ensuring compatibility, and managing dependencies. Without a proper versioning strategy, teams can face issues like dependency conflicts, regression bugs, and deployment failures. Versioning also facilitates collaboration among team members, as it provides a clear history of changes and updates. In the context of DevOps, versioning is crucial for automating build and release processes, ensuring that the right versions of code and packages are used at every stage. Semantic versioning, SEMVer, is a widely adopted versioning scheme that uses a three-part version number: major.minor.patch. The major version increases when there are incompatible API changes. The minor version increases when functionality is added in a backward-compatible manner, and the patch version increases when backward-compatible bug fixes are made. This clear and predictable versioning system helps developers understand the impact of changes and manage dependencies more effectively. Semantic versioning offers several benefits. It provides a clear and predictable way to communicate changes, making it easier for developers to understand the impact of updates. It also helps in managing dependencies, as teams can specify compatible versions of packages. This reduces the risk of breaking changes and ensures smoother integration and deployment processes. Additionally, semantic versioning supports automated tools and workflows, enabling more efficient and reliable build and release pipelines. To implement semantic versioning, teams should establish clear guidelines and practices. This includes defining versioning rules, setting up automated tools for version management, and integrating versioning into the build and release pipelines. Teams should also ensure that all code changes are properly documented and versioned, and that dependencies are managed using compatible versions. By following these practices, teams can achieve a consistent and reliable versioning strategy that supports their development and deployment processes. Date-based versioning is another approach to versioning that uses dates to identify versions. This method is often used in environments where releases are time-bound, such as in continuous delivery or agile development. Date-based versioning typically uses a format like YYYY.dd or YYYMMDD, making it easy to identify when a particular version was released. This approach can be particularly useful for tracking releases and ensuring that the latest updates are always deployed. Date-based versioning offers several advantages. It provides a clear and straightforward way to track releases, making it easy to identify the latest version. This can be particularly useful in fast-paced development environments where frequent releases are common. Date-based versioning also simplifies the management of release schedules and ensures that updates are deployed in a timely manner. Additionally, it can help teams align their versioning strategy with their development and release processes, supporting continuous delivery and agile practices. To implement date-based versioning, teams should establish a consistent format for version numbers and integrate this approach into their build and release pipelines. This includes setting up automated tools to generate version numbers based on the current date and ensuring that all code changes are properly documented and versioned. Teams should also establish clear guidelines for managing dependencies and ensuring compatibility between different versions. By following these practices, teams can achieve a reliable and efficient versioning strategy that supports their development and deployment processes. Choosing the right versioning strategy depends on several factors, including the nature of the project, the development and release processes, and the team's preferences. Semantic versioning is ideal for projects with well-defined APIs and a need for clear communication of changes. Date-based versioning is suitable for environments with frequent releases and a focus on continuous delivery. Teams should evaluate their specific needs and choose the versioning strategy that best supports their goals and processes. Integrating versioning into build and release pipelines is crucial for ensuring consistency and reliability. This involves setting up automated tools to manage version numbers, ensuring that the correct versions of code and packages are used at every stage, and establishing clear guidelines for versioning practices. Teams should also ensure that versioning is integrated with other aspects of their DevOps processes, such as continuous integration and continuous delivery, to achieve a seamless and efficient workflow. To achieve a successful versioning strategy, teams should follow best practices such as defining clear versioning rules, using automated tools for version management, and ensuring proper documentation of changes. Teams should also establish guidelines for managing dependencies and ensuring compatibility between different versions. Regular reviews and updates to the versioning strategy can help teams stay aligned with their goals and processes and ensure that their versioning practices continue to support their development and deployment efforts. Let's explore a case study of a team that successfully implemented a dependency versioning strategy. The team adopted semantic versioning for their API development, ensuring clear communication of changes and compatibility. They integrated versioning into their build and release pipelines, using automated tools to manage version numbers and dependencies. By following best practices and regularly reviewing their versioning strategy, the team achieved a consistent and reliable workflow, reducing the risk of breaking changes and ensuring smooth deployments. Implementing a dependency versioning strategy can come with challenges, such as managing complex dependencies, ensuring compatibility, and maintaining consistency across different environments. To address these challenges, teams should establish clear guidelines and practices, use automated tools for version management, and regularly review and update their versioning strategy. Collaboration and communication among team members are also crucial for ensuring that versioning practices are followed and that any issues are promptly addressed. In conclusion, designing and implementing a dependency versioning strategy is essential for ensuring consistency, compatibility, and reliability in software development. By adopting practices such as semantic versioning and date-based versioning, teams can achieve a clear and predictable way to manage changes and dependencies. Integrating versioning into build and release pipelines, following best practices, and regularly reviewing the strategy can help teams achieve a successful and efficient workflow. The next steps involve evaluating your current versioning practices, identifying areas for improvement, and implementing the strategies discussed in this presentation.